move on forward. There we go. All right. So what we want to do today is we're going to divert from the normal path. All right. Everybody in this group is in CSCYB or a related one in IT, and that gives us an opportunity to build a little bridge between what we're doing here and what you'll be doing next semester in your ethical hacking class. Now, there's a special configuration of the TinyNet that makes it a good victim network. And there's also a few little tools that we have available that to do a couple of interesting things, especially across the network. And it demonstrates some, I think we'd safely say, a little bit more advanced techniques, and advanced capabilities that are built into the operating system. They're normal capabilities built into the operating system, but we need some kind of advanced techniques to understand them and to take advantage of them. Now, we only have time for a kind of quick review, but there is more complete documentation on the My TinyNet site. All right. So really, if you're going to be a guru at this, you need to read up on your documentation and practice a bit and exercise your imagination, because that's what makes a good hacker, is imagination. It's not only about the technical knowledge, but that also is, I suppose, equally important. All right? But it's how you put that to work and how you apply it that really makes the difference. So what we'll do is we'll start off with one kind of straightforward thing, which is getting a shell on another system. Right? Now we're going to have an unfair advantage since we know root passwords and we've got root privileges everywhere, right? But that's appropriate for ethical hacking. It's appropriate for our kind of sandbox testing environment. So we'll do that today, and then next week, all right, we'll talk about the other setup for the TinyNet, where it automatically generates traffic and sends it across the network, which makes it a great target for hijacking TCP connections or examining the traffic. All right. There are, I don't know, next semester when you go into ethical hacking, you'll be using a set of tools called Metasploit, that has a lot of scripts written in Python, right, that are already made to do particular things like attacks and things like that, all right? But at some point, using the things that are already there out of the box, it's good, it gives you some experience, but you need to move a step beyond that. Right? And so this is one step outside that box. All right, so on the assignment, right? Way down at the bottom down here, there are two special recommendations for ethical hacking. Right? And since the schedulers have cooperated and divided us up like this, all right, we'll look at this one next week, the NetR traffic setup and what it is to set up NetR, what that actually means, all right? And we'll look at this one today, Port Knock, all right? This is actually kind of related to what we talked about last week, all right? Because last week we were talking about IP tables and the packet sniffer, examining every packet as it comes through the network, all right? And we've got another utility called NOCD, all right, that does exactly that. But instead of listening for traffic that we want to allow or deny, NOCD examines the packet stream coming across the network and looks for a particular pattern that we can call a knock sequence, all right? Like two long knocks, knock, 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 too long, too short, like that. And when it receives that signal, when it senses that signal coming across the network, then it executes a command that we have configured it to execute, all right? And in this case, what we're going to do is we're going to have it execute a shell for us, all right? Now, there's two ways to do that. One called a reverse shell, one's called a remote shell, all right? But, and somebody told me that this was called a bind shell, which I think is probably technically accurate, but I think that's one that's kind of limited to Metasploit documentation, all right? So we're going to set this up, and we're going to use, there's two ways that we can do it. One using Netcat and one using bash sockets. And this is what I was saying about looking at utilities and facilities that are built into the operating system. But they require a little bit deeper understanding of how things work. So we're going to take a brief overview on this today, all right? But I want to encourage you to look into the documentation and get a little further and deepen your understanding of the operating system facilities that we're taking advantage of here. So, on the MyTinyNet site, where'd you go? Here you are. All right. Down here on the menu, there is the section called extensions. All right. And that's where we find our C compiler. Don't worry about the X windows. That's for a further extension of the TinyNet that has been kind of on code freeze for a while. But there's one down here called Breaking Bad. And that takes you to a completely different section of the site, right? Where it explains the NetR network, right? For red team exercises and ethical hacking, all right? And the whole idea of this is people, man, you should know by the end of this class, you should know just from the base system, what a lot of work it is to get the system set up and get it running and get it reliable. And people really resent it when other people come along and try to destroy all of their hard work. But that's what you get to do with ethical hacking and penetration testing. You spend all this time building up the system, and then you spend a whole bunch of time trying to tear it down, get past all of the security measures and raise some havoc inside, right? And there are a few things here, these are just some ideas, and we'll talk about our network itself, right? As I say, we'll talk about this next week, all right? But on the topic of remote and reverse shells, right? We've got our NOC-D on all of our virtual machines, so we don't need to go into any special effort to get this one set up and running. So just here at the top, it says under other resources, there's a few extra references here. All right. The vulnerable VMs takes you to a site called VulnHub, all right, where people who have put up various virtual machines with various vulnerabilities, all right, for you to download, and a lot of these work well with Metasploit. The only problem is they're a little bit big, all right, and running one of these and running Kali Linux at the same time, you're going to tax your system resources. All right, the exploit database, all right, there's just a few links here that you might find interesting, all right? But basically, what this page is about, all right, just a kind of total scenario, right, of what the red team needs to do. Reconnaissance, scanning, gaining access, maintaining access, and covering tracks. All right. So scanning, that's what HPing is great at. All right. Other people will use other tools, but HPing can do this. If you look into HPing a little bit deeper, take a look at the documentation. It's a great tool for scanning. Right? But our focus here is maintaining access and covering tracks. All right. So as it says here for the red team, combining a remote or reverse shell with NOC-D is a fine method for maintaining access and covering tracks. All right. Once gaining root access has been taken care of. All right. So there's a whole process there. And again, you've got other classes where you're going to deal with that in depth. All right. We just want to look at one technique that works for these. All right. And that's what part C is about. Analyze the footprint of our reverse shell in the output from the process list, TS minus AX. So there's two ways to do this, all right? One is using a utility called Netcat, all right? Now, Netcat is kind of too well known, all right? but actually it's underdocumented in most places. All right, so let's just take a quick look at the Netcat page to get a little bit familiar with it. Oops, it's in the My TinyNet home under Utilities and Netcat. All right, and basically what Netcat does is it sends things across the network, or it listens for things coming across the network. And it doesn't do anything other than that. All it does is send traffic and catch traffic. All right, the way we generate it, what we pipe into Netcat and what we take out of it is entirely up to us. And this is a systems administrator's nightmare, because if people get Netcat on your machine and can get access to it, right, they can do whatever you let them to, right? So here's a note from the developer, right? But the idea here is we can use Netcat as a client, or we can use Netcat as a server, right? And again, not going to go into this in any detail, right? But this is the one thing that's really important to know, right? And this is the part that is underdocumented, all right? Is there are two versions one called GNU, I'm sorry, one called Classic and one called BSD, right? And there's a GNU one that is pretty similar to Classic Netcat, right? But all of these have slightly different command line switches. They all have slightly different characteristics. So it's really important to know, or to be able to tell, which version of Netcat people are talking about in their instructions, because nobody ever does. You have to figure it out for yourself, right? But clue, the BSD version seems to be the one that is stock with Ubuntu Debian packages. If you apt-get Netcat, all right, you're going to get the BSD version. If you're using Kali Linux, however, they have compiled their own Netcat, all right, which is basically Classic, but with one extra little twist, all right? But the good thing is TinyNet clearly labels them, all right? One Classic is called NC, and the other version is called BSD-NC, all right? Because each one has some characteristics that make it special, all right? And we use them both in the examples, right? But we can, especially this BSD version, where it keeps the connection open after a client quits. That's a big strength of the BSD version. So we can use Netcat to put a message in a log file. That's kind of fun, all right? We've got a script to do that if you install the patch ISO. Okay, we looked at that briefly last week. There's a basic exercise here about using Netcat, but this part here in terms of background is important for us now, all right? The idea of a named pipe, all right? When we do, I'm going to have to smallify this a little bit more. There we go. All right. When we use a pipe like we've talked about before, ooh, lost my place here. All right. Pipes like this just sends the output of the first command, just pipes, standard out of this one to be standard in of the next command. A named pipe appears in the file system, all right? It's permanent, but basically we use it exactly the same way as we use this pipe, right? Except we need to put things into it on one side, and then we need to specifically read from it on the other side. But basically it performs the same function, except it's permanent in the file system. It takes in the standard in, it takes in the standard out from one source and clears itself out when another process reads that information from the pipe, right? It's kind of like, I don't know, I don't want to say this, all right? Different from saving it to a file. Saving it to a file, it's always saved, all right? We put it into the pipe. It's there until somebody else comes along and reads it out of the pipe. And that's a trick that we're going to use, right? This one has a little bit of a sample shell script here. It demonstrates how to use it, right? In a benign and normal sort of a way. This one has another different script over here that shows how to use it in a less standard or normal way, all right? So what we need to do here is we need to create this as a shell script. Now, I should have done this before, but yeah, so now let's give it a try. All right. So this is on all our TinyNet machines. I'm just going to set it up here on my LDAP host. All right. I'm logged in. So let me just shift this over here for a second. And I'm going to just create a command, create a shell script here real quick. Go away. A single quote, hash, bang, bin dash. Not at, hash. To NCSH. And quickly change the permissions. Odd 755 NCSH. And while I'm here, we'll do the same thing for the other one. REMSH. Doesn't matter what they're named, anything like that. And startup MC here. You know what? My NCSH F4 to edit. And just get these commands in. Pipe. We'll put it in temp because temp is place where weird files show up. And we'll call it dot p underline box twice. All right. Like that. And then we'll put a trap RM, the pipe that we created. And cat hands on one line, like that. And trap the exit signal and sigterm. Now again, we're doing this quick, all right? And then we MKFIFO, make FIFO pipe. And here's the fun part, cat, to the pipe, all right? So standard out from cat goes into the pipe. Then we pipe that, normal pipe, dash, minus I. Then some file descriptors, 2 pointer, standard error, and 1, put standard error with standard out, and pipe that to BSD netcat. And minus L for a listener. That's a minus little L, not a 1. 2, 3, 4, 3, 5. That's our port number. And then redirect that. Oh, guess what? We're round tripping this. All right? Reading out of the pipe and into it. String pipe again. And send it to the background with amp. Pointer and 1 BSDNC minus L 2, 3, 4, 5 pointy string pipe, and wow, look at that. All right, F2 to save that one, and F10 to exit. While I'm here, I'm going to set up my second one. Second one is actually, in some senses, simpler, and some senses weirder. All right, that one's a little bit farther down. Exec dash minus I. Ooh, this one is really strange, but dash minus I, and then 0. And it in. Stroke dev, stroke TCP, stroke attack IP. What's my attack IP? My attack IP is going to be 192.168.76.222. I'm going to use my mail host as my attack platform. 192.168.76.222. 192.168.76.222. All right. And then 1 pointy and 0. 1 pointy and 0. 2 pointy and 0. All right. Now, this looks really, really weird. And it is really, really weird. Somebody really twisted had to think this one up. All right. But basically what this does is it starts Bash as an interactive shell. All right. And then the 0 and reverse pointy at the beginning says all of this stuff is coming into standard in. All right. So everything from this dev TCP goes to standard in. All right. And then we redirect standard out, 1 pointy and 0 to standard in. And we redirect standard error, 2 pointy and 0 to standard in. And the upshot of it is when we start this up, we'll be able to get the shell on the remote machine. So F2 to save, F10 to exit. All right, now let's see if I did this right, but I think I did it wrong because I created both of those on the same server. All right. Let's start with a remote shell, netcat named pipe. All right. And we want a one-time listener that cleans up the FIFO. So that's explained here in the script. All right. So we run this script on the victim, and on the attack side, we run NC for netcat. This is basic, classic netcat, our victim IP, and the port. All right, so that everything we type on this machine gets sent across the network to port 23435, where my NCSH script is listening. That's the last line there. All right, BSDNC minus L. All right, so what's going to happen is everything that netcat sends across is going to get sent, piped into Bash. Everything that Bash outputs gets piped into netcat, right, via our named pipe in the file system. So let's try it out. NCSH. No such file or directory. What happened here? Well, let me just see if it works anyway. 66.157. Let's see. 192.168. What do we have? 66.157. Ooh, no ports to connect to. Ouch, what did I do wrong here? My make FIFO didn't work. All right, so I'm going to Control C to get rid of that and quickly figure out what's going wrong here. What did I do? It should have worked. All right. This is why I hate live demos. All right. Log 1090, 1099. The little file exists. It was already there. What happened with that? Ouch. Ouch. Ah, now it works. All right. Back here to my mail host. Let's try this again. Oh, 2, 3, 4, 3, 5. That's what I needed. All right. Let's see what happens here. LS. Nothing. Bad file descriptor. Oh, ouch, man. Need to. So we'll see this again. Ouch. What happened here? How come I don't get a listener here? You got 1125 and 1135. All right. I still don't have my, yeah, there it is. BSDNC minus L 23435. Maybe that's what was getting it confused. Job control in the background, bad file descriptor. Okay. Well, I'm going to have to see what happened with that, but it must be a typing mistake somewhere here. Because it works fine normally. Normally it works fine, and today it won't. I hate it when that happens. Right, one more chance, and then we'll try the other one. Yeah, see? There it is. It's still not cooperating with me, and I don't know how to fix it. So let's try the other one. See if we can make that one work. All right. This is a script that needs to be run on the victim. And the alternative for the remote shell, we put the reverse shell, we put a simple listener on the local attack host and pipe an interactive shell from it to it from the remote host. All right, let's try that for a change. BSDNC. All right, this is my mail host. BSDNC minus LK V 23435. You know what happened. All right. PS minus AX. Let's see if we can figure out what's happening here. Is that already in use? Oh, crap. Come on. There we go. Let's try port 23433. Let me just edit my script here. And like that. All right. Oh, I think I forgot to put a port number on that. 23433. Good thing I did that first. There we are. Okay. All right, now let's see if we can do this. Huh. Now I think we got it. Connection received. Oh, look, look, look. This is what we're looking for here. All right. This is my mail host. All right. And my prompt has changed from root at mail to root at LDAP. All right. And now I'm executing my commands on the remote machine, all right, with all of its command prompt. And the only thing I see here is, oh, the BSDNC is from before 1157. I still don't know why that's not working. All right. But this is my bind shell, all right, or my reverse shell being sent back to my attack host from this side over here. All right, so I'm just going to Control C this. All right, and as you can see, Netcat, when I Control C'd it on this side, all right, terminated process over here. And 157. I'm going to figure out what I did wrong on that typing mistake, all right, because that one also works perfectly. All right, never mind. All right, if you have problems with this, let me know. All right, the complete explanation is here. So once we have these scripts up, then what we do is we use Nocti to trigger these scripts. All right, so we can use hping here. We can use hping to send any kind of a packet that we like. All right. And what we do is we go into the Nocti configuration file and we set up a configuration that says, listen for one packet on port 1080, one UDP packet, port 1080, 3 of those within 5 seconds. And when we see that file, all right, execute this script. This one, we can use TCP or UDP. We can use whatever port we like. All right, Nocti is a packet sniffer, all right, but it doesn't try to filter the traffic. It just tries to identify this pattern in the traffic stream. All right. So this one, for my reverse shell, right, I'm going to use a TCP packet with the SYN and RST flags set. All right. We need to send 3 of those within 5 seconds. When you do it this way, you can mix up these port numbers, you can mix up the protocol, you can do whatever you like with it, but it's really simple like this because you can just use hping -C3 and blam, they're gone. all right? And whatever script we want to execute, we just put that in down here. So that's really simple, all right? We just put it in the configuration file above the current example configuration. We don't need to worry about that at all right? Mailhost will be the attacker. Startup command, etcrc.nocd. This is only for the gateway. We need to specify the interface. All right, the scenario here is the Mailhost attacking the gateway. All right, for us, it doesn't matter because I'm using the LDAP host and the Mailhost. All right. Let's take a quick look at this one, my LDAP server. All right, I've got remsh. All right, so let's do this. Just need to get into etc, and there's no K's on that list, so let's look down here a little bit. nocd.conf, F4 here, all right? And just open up some space here, and I'll just put in a tag that says remsh. And sequence. Equals NAT UDP, comma, AT UDP. All right. Now, when you look at the next one, it says 7,000, 8,000, 9,000. That just means an empty TCP packet, all right, one on port 7,000, one on port 8,000, one on port 9,000, all right? Sequence timeout. And no TCP flags on this one. Is OT REMSH. All right, so I can start ready. F2 to save and to exit. All right, and what were we saying here? etcrc.nocd. Oh, you know, it's already there. So first thing I better do is set the execute bits on this. There we go. And let's just check it real quick. Start nocd. User sbin nocd minus d. All right. This I ETH3, that's only for the gateway. So we're all cool with this. So let's, let me just, All right. That minus TULP. Right. Doesn't show up in netstat. So how not that? All right. It is still listening, but it doesn't, it's just in the background listening, okay, for, it's just in the background watching the traffic. It's not a service that we can contact except through this pattern. All right. Now, what do I need to do here? So I need to set up my listener here. Right? And then I need to do an Alt F2, get a new login screen, and send my knock. Oops. All right. hping minus C3, that's a SR. All right. hping minus C3 minus P180 minus UDP. There we are. All right. Otherwise, it's the same as the other ones we've been running. So hping minus C3, oops, this UDP minus P1080 and the IP address minus P1080 and the IP address is 192.168. This one is 76, so it's got to be a 66 dot something. 6.157. All right, and ICMP port unreachable, it returns, but Alt F1. Oh, it didn't work. What happened here? Oh, Schmidt, I hate it when things don't do what they're supposed to do. ICMP port unreachable. I'm having a bad day today. All right. Ah, here's a bash minus I already running. Knock D minus D. Oh, all right. I forgot to look at the instructions. It says when you do this, you have to wait because knock D is slow. All right. But I've got my LDAP prompt running here. All right, and I'm logged in. I'm in the root directory. I'm in the root home directory. All right, and all right, I've got my Nocti and Bash living there. All right, So I've got two Noctis open now, but it doesn't really matter. I can kill that process. Minus 9, 1, 2, 3, 7, and we're done. And we are done. We're out of time. You know what? I'm going to have to find a way to get the timing right for that little demo. You know what? But it's quite fun. You know what? And the remote reverse shell is the holy grail of the hackers. All right. And so just give it a try. All right. But it's kind of up to you to get up with the documentation, because we just don't have enough time to devote to it. So thank you so much, and have a great weekend. All right. We'll get together bright and early next Thursday. Timetable is out and it hasn't changed. We'll get together bright and early next Thursday and discuss some of the last topics. And this time next Thursday, we'll talk a little bit about NetR as a network that you can feel free to attack, right? Because it's totally under your control, and you'll only be destroying your own hard work that you've devoted to getting it set up. So, hasta la vista.
Sir, I have a question I wrote in the chat. Could you possibly answer it?
Sir, could you please update attendance? I have a problem with AP space. Sir, you there?